Hello everyone again and welcome to my channel. In here we'll be looking at dienes and specifically the stereochemistry behind dienes and how they are able to interact with dienophiles to form cycloaddition reactions. Dienes are pretty much either forming three possible stereocenters or stereochemistry in there. We have either we get the Cis-cis formation or we have the Cis-trans formation, or we have the trans form of this particular diene. Now let's go in details each of these particular stereochemistries that this diene they possess before they actually interact with our dienophiles to form our final product. So first of all, we're going to be looking at the Cis-cis form of our diene. Now the Cis-cis form is a situation where, for example, we have this particular compound over here and this one over here, it interacts with a triple bonded species over here where we have withdrawing groups on the terminal ends, and now our regular interaction is that we're going to have a nice orbital flow where this electron moves over to this particular carbon over there, and then we have one of the one actually moving over there, and then this other bond moves over there. As a result of that, we have this nice flow of electrons, and this leads to the formation of our product over here. Now take note that this product over here is looking at it from the top, so we have this one pointing coming out over here, and here we have this, that over there. We have our hydrogens, which are the terminal hydrogen atoms over there, and here we have CO2 Me over there. Now if we're trying to look at this in terms of the various orientation of the molecule as is aligned above this particular page, what we get is this particular structure over here. It's a double bond which is over there. This angle over here, or this bond that has been formed over here, is actually pointing upwards, and over here we have our other double bond which is over here. And take note that these compounds over here are cis with respect to each other. So what we realize here is that if our cis species is actually used over here, we tend to form our cis product over here. As a result, as you see that the hydrogens are actually pointing downwards over here. Now the next one we're going to be looking at is the point where we look at our trans diene that is involved in this particular cycloaddition reaction. Now this trans looks at, for example, we have a phenyl group attached to this double bond, and in here we have this trans here, and on the other side here we have this trans over here. Take note that I'm just making this to be symmetrical in terms of the orbitals by including the same functional groups at the terminal ends. And what we note here is that this particular point of symmetry is a C2 axis, which has a C2 axis of symmetry over there. And then what we get here is a nice flow of electron, thereby this double bond forms a single bond over here, double bond forms a single bond over here, and this double bond really forms a double bond over here. And what that leads is the formation of our product, where we're going to have a nice stereocenter which are symmetrical to each other in our product over here. Now take note that this our copper over here, however, since we have our trans here, we don't get a trans product over here, we still get a cis product over here where the phenols or the phenyl are all pointing upwards and our hydrogens are all pointing downwards. Now we need to note that both have a plane of symmetry throughout, and the products must have this plane of symmetry as well. Now because of this reaction is concerted and non-significant, movement of substituent can occur in this particular case. So that is how this particular compound is being formed over here as a result of the nice concerted reaction that is happening over here, where despite the fact that we have our trans dienes over here, we still have this nice pushing of bonds both in either in the cis-cis case or in the trans-trans case. But this is not trans-trans, this is still cis-cis because we get our final product with our all cis over here. So that's about it for the trans-trans diene. And last and foremost, we have our cis-trans diene over here. And what does this cis-trans diene focuses on? This cis-trans diene focuses on one part of our diene having a cis configuration and the other point having a trans form over here, where there's a hydrogen and a hydrogen is over there. And this is our R group. R group could mean anything, but they must be the same. And this is considered to be our homo as usual, because dienes are mostly homo, they donate electrons. However, we have our LUMO, which is the same reagent with what we have over there, where this is our electron withdrawing, making this to be electron lacking and accommodates electrons coming in. Now if we do our cyclization reaction, now this bond over here forms a single bond over here, double bond forms a single bond over here. However, we have this double bond reforming a double bond over there. And what do we get as a result of that? We get our product, which is, it's going to be a tough one to draw, but I'm going to make it kind of realistic. So these are our group, these are double bond over here. On the other side we have a hydrogen pointing at the other side over here. However, we have different positioning of our R groups as a result of the cis-trans here, where both of them are actually trans with respect to each other. And what we have over here is our double bond being formed over there, and we have our CO2Me and our CO2Me over there. So what do we got over here? You see our R groups are in the other direction, one trans with respect to each other, due to the generation of or due to the diene, where the diene is actually cis and trans. So what we got over here is that the unsymmetrical diene generates two substituents that are clearly ends up on opposite sides of the new 6-membered ring, which is what we got over here. So that's about it for the differences between various of the conformations or stereocenters of our diene, where the cis-cis gives us a cis-cis conformation over here. On the other side we have our trans-trans diene, which forms a cis-cis positioning of our substituents with respect to the diene over there. And last and foremost, our cis-trans generating a trans positioning of our substituents on the diene. So all the same guys, thanks for watching and following me through this. I appreciate it. Please hit a comment down below and let me hear your thoughts, and don't forget that I'm going to be posting more videos related to organic chemistry, biochemistry, and also other interesting science classes that you may be experiencing at the university level. All the same guys, have a good day. Peace, love you all, and see ya on my next video. Bye.